Unit 3, Tutorial Assignment 3. For this assignment, we are asked to pick 3 boxes and make tic-tac-toe. For my boxes, I chose 1, 2, and 3. For 1, we are asked 2 parallel wires a distance d apart carry currents in the same direction. One wire carries twice the current of the other. In which direction is the magnetic field midway between the wires? To start, I drew a picture to help me understand. The picture's right here. So we know that current I is half of I2. Well, I made it so you think of it more as I2 is 2, I1. And so we know that the point on B1 will be positive. This one's B1. Be positive because the point would be, so right now the point would be on my right side. So when the point is on this side over here to my right, it is going into the page, which would be positive. And B2 would be negative because when the point is over here, it is going out of the page, which would be negative on the y-axis. So we know that B total is B1 plus negative B2 because we already established that B2 will be negative. So since B2 will be bigger due to having a bigger current, 2 times the current, if we would use numbers to describe it, it would mean B total will be negative because it'll have more B2. So the midway point would be out of the page. Next, I chose 2, which says find the direction of the induced current in the ring. So we know that field lines go from north to south. So in this instance, the field would be going up. So be going up from north to south, so up. And we know that flux is increasing because we're getting closer to the loop. So that means the field will be opposite, which means we have to flip our thumb over, which means the current would be going clockwise. So clockwise like that. It's like that. Next, I picked number 3, which says a straight wire is horizontal in the plane of the page and carries a current to the left. An electron is moving toward the wire from the bottom of the page. In which direction will the electron experience a force? First, we have to use right-hand rule 1. It says the current is going to the left, so we point our thumb to the left. So your fingers would curl clockwise, so this way, like that. And so the electron is on the bottom of the page, which means the electron would be going out of the page that way. Now we have to use right-hand rule 3. The field of the electron is going up, so we have to point our fingers up, like that. And the direction of the field is out of the page, which means our thumb will be pointing to the right. But this is asking you for the motion of an electron. The rules are made for a proton. So since it's an electron, to get to a proton, we just do the opposite, which would mean that the direction the electron experiences a force would be to the